We believe our universe is real, that the ground beneath our feet is solid, and the stars above are fixed. But what if it's all a grand illusion? What if reality is far stranger, more fragile, and more complex than we can possibly imagine? Some of our most brilliant physical theories, when pushed to their absolute limits, suggest exactly that. These aren't just philosophical musings. They are the startling possibilities that emerge from the mathematics that governs our cosmos. First, the holographic principle. It suggests that your life in 3 dimensions, every sight, sound, and feeling, might be an illusion. This theory, born from the physics of black holes, proposes that our entire 3D universe is a complex projection of information stored on a distant, 2-dimensional surface that surrounds us, like a cosmic hard drive. Everything that has ever happened and ever will happen is just the unfolding of a script written on the edge of the cosmos. Your sense of depth, your freedom of choice, all an elaborate hologram. But what if the illusion is even deeper? The simulation hypothesis argues that our entire universe is a hyper-advanced computer program. The logic is simple. If any civilization ever becomes advanced enough to simulate a universe, then simulated universes will inevitably outnumber the one base reality. Statistically, it becomes almost certain that we are living in one of the simulations. The laws of physics are just lines of code. Your consciousness is part of the program. And the most unsettling part, a simulation can be turned off. Perhaps the most terrifying theory is that our universe exists in a fragile, temporary state. It's called false vacuum decay. Think of it like a drop of water perched on a mountaintop, stable for now, but not in its lowest energy state. At any moment, a random quantum event could nudge a patch of our universe into its true, more stable state. If this happened, a bubble of true vacuum would expand at the speed of light, instantly rewriting the laws of physics and erasing everything it touched. We would never see it coming. In a flash, everything would simply cease to be. But for every end, there is a beginning. Black hole cosmology offers a potential answer to the question, what came before the Big Bang? The math describing the infinitely dense singularity of a black hole is remarkably similar to the math of our own universe's origin. This theory suggests that every time a black hole forms, the matter it crushes doesn't just disappear, it bounces and expands into a new, separate spacetime, a child universe. Our entire